Assalamualaikum warahmatullahi wabarakatuh. My name is Kabaria, and today we will like to present our Lab 3 AC High Voltage Measurement and Monitoring. Okay, my group mates are Kumaran, Laki Subramania, me myself Kabaria binti Ramli, and Siti Nur Atira binti Ibrahim. And I will explain about section 1. Okay, for this section, the instruction is construction of parallel AC high voltage measurement using frequency converter and picoscope. Figure 1 shows the parallel connection technique for obtaining AC high voltage generation through the kit control display and the picoscope. And then by using the inner circuit contact conductor begin from the termination of 100 picofarad, followed by coaxial cable, adapter A, secondary unit of AC, adapter B, BNCT junction, long coaxial cable X to the FC or VM1, and long coaxial cable Y to the picoscope. Okay, as we can see here, the BNCT junction is connected to the Y to picoscope and X to frequency converter. And then the procedure of the key control is the secondary unit must be connected to the VM1 to measure 7V RMS, and the alarm will turn into red. So the next step is we must clear the alarm. So for picoscope, first step is we must select channel to activate, and then select AC for coupling and filing, and third, select voltage to measure, and then number 4, put voltage divider ratio, that is 19651 to 1, and then the last step is push reset button to run. Okay, next, the safety rule. The frequency converter cabinet is grounded with power ground from the input and also with the low inductive ground connection. Secondly, the ground switch does not replace the functional safety of an earth rod, and you must always check that live parts are grounded correctly. Third, the normal switch function can be used in any state of the system. Shielded cables must be used for interlock connections. The cable must through the connectors. We must ensure that braided copper cable need to connect to frequency converter, the floor pedestal, and the secondary unit. The end of the safety circuit is a termination or a bridge. Next, I will pass to my group mates to continue to their section.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Atira. I will present about section 2 for lecture. First, the Ethernet cable is used in the two-panel mixed trace and reform operation, and there are 8 slots in the membrane device. The main antenna on the control of the package. The range is identical to a standard oscilloscope consisting of 4 channels attached to the measurement area of channel A, B, C, and D channel. To do some injection, make sure the door is closed correctly and that the latch is triggered. In order to select the correct step, we must consider the properties on the secondary device with serial number and name of the usage. Then, in the measurement setup, either for package power or picoscope, there is advisable divisor ratio minimum. Making conveyance and then 51.1 volts. There is 6 VM1 and VM2. VM1 consumes 1 and 2. VM2 and slot AC for VM2. VM2 slot 3 and 4 for measurement and frequency measuring below the VM1. VM2, VM3, VM4, VM5, and VM6. There is a condition that it cannot be injected while the red colors are shown. Click the reset button and you are going to bring the alarm toggle. takes place, then there is a console where the door doesn't shut properly, and you click the emergency button to power off the situations. First close button for emergencies, then properly lock the door. Lastly, click the button reset. Then no setting must be altered or FC installation provided by the manufacturer. Then for customer setup, there is an improvement in the number of manual measures we will use to increase and minimize 0.1, 1, and 10. As a manual book for the supplementary calculation test, the improvements and 1.4 by duration and the cost. The system was limited to 7 grams only if 10 grams is chosen. We have to set it then. The secondary serial number for kit like 10 EAI 3000 is limited. We were able to set the sample number of sample points with the position of the sample interval 5 until 10 The active trigger is for impulses that control the signal and ensure that AC couple is chosen by the channel. Set the range of 10 volt and then set the offset to 10 as the initial waveform condition. We have also AC/DC and brightness with RMC indicated in its impulse sequence. These characteristics are also frequent, HD, and frequency of distortion. When logging, click channel A, AC, then click reset. Lastly, when the setup press is done and the device begins and the lamp switches begin to work, sound is made and the switch base can act as safety system. The green line indicates that the machine is ready. Nobody is able to control the changes to the working. Then I will pass to the presentation for my group member, which is Kumar. Thank you.
A good day to our lecturer, Dr. Zikri Abadi bin Baharudin, and my name is Kumaran Analaki Subramaniam. My metric number is B071710385. I'm going to explain about the Lab 3 ACI voltage measurement and monitoring from high voltage subject, and my part is about section 3. First of all, in this experiment task, I will able to expose on the application of the kit control 4.0 high voltage construction kit, which is the latest technology from Herley Hypertronics Switzerland. Moreover, in this experiment, I will able to explain using a picoscope 3000 series for displaying the AC signal of a AC high voltage. The system from a kit 4.0 integrated state-of-the-art technology offering variable frequency experiment to me with a equated security circuit. It integrates a frequency converted front end digital oscilloscope for voltage current measurement and a completely refreshed accessory set. The kit 4.0 is powered by a frequency converter, a device to convert a grid frequency with a voltage to another frequency and voltage. In this section 3, I should in this section 3 is my part is comparison of analysis the reference signal from kit control and displaying signal from picoscope. First of all, I will describe the calibration of a AC output voltage and able to construct the table of comparison between the result of the reference kit control and display picoscope. Next, I will show the calculation of percentage of error between the values, and I will also discuss about the differentiability between the reference and display the based on calibration fact, and last is a conclusion regarding on the lab seasons. First of all, when the output voltage so is 0%, so the reference voltage from a kit control is 533.753 watt, and the voltage in display picoscope is 946.07 watt, and the error from the comparison percentage of error compare between that is negative 77.25%. and the frequency hertz we get is 50 hertz. At the last of the experiment, when the output voltage shows 68.7%, the reference board from the kit control shows 71.961 kilowatt, and the display watt show in the picoscope is 70.74 kilowatt, and the error is just 1.70%. Frequency is same. That is, I would like explain about the discussion of this project. From the table above shows the percentage of the error between the reference signal from the kit display and the display signal from the scope. At the first data, the AC output shows 0, at the reference voltage shows the 533.753 kilowatt, while the display voltage shows the 946.07 kilowatt. So the error is negative 77.25%. The reference signal voltage shows a bit higher value compared to the display signal. Last part is the conclusion. Based on this experiment above, we are able to provide two methods for measurement and monitoring AC voltage signal by comparing AC monitoring system and a picoscope or display or digital oscilloscope with the computer software base. First, we learn to use a FC frequency FC and a picoscope to measure parallel AC or high voltage, and a safety rule in a FC cabinet. Other than that, able to know the steps to setting picoscope with the Ethernet cable. At the last, able to calculate the percentage of the error comparing the result of reference kit control and a display percentage. Thank you.